Anand. My team members are Nadesh, Naveen, and Alvin. We are the students of Vellore Institute of Technology. We take the problem statement of current measurement accuracy for CT powered devices while preventing the saturation. Our concept and scope of solution is we are using zero crossing detector to detect the change in frequency of the secondary current signal and phase locked loop system to fix the frequency as 50 Hz and prevent the voltage spikes across the switching using snubber circuit, and we design an AC to DC converter and DC to DC converter for stable the power supply. We got more information from the mentor sections and we got the clarity on the circuit design to measure the input current and power the device at the same time. SWOT analysis. We are concerned about our strength, weakness, opportunities and threats. We figure out one of the main reason of saturation at secondary side, which is change in frequency. We are considering it is one of the main strength, and our weakness is to figuring out the rating and class of transformer in this challenge. And we gained a lot of exposure, which is considering as an opportunity for us to learn more about CT and threads. The cost of estimation is considering as one of the main thread for us, and my teammates will explain about the circuit.
Phase lock loop is used to fix the phase and frequency of an output signal with an input signal. The input signal which we are getting is from the zero crossing detector. As you see that the input signal of the secondary side is being detected by the zero crossing detector, and we are getting a blue line as an output signal from the zero crossing detector. This output signal blue line is being given to the phase lock loop to get an feedback and to fix the frequency and phase value.
Circuit of the CT. Here from the phase of the auto transformer, a wire goes through the CT to the rheostat. Then from the other end of the rheostat, a wire is connected to the neutral of the auto transformer. Then through a oscilloscope, we are getting the output from the CT. Now this is the output waveform of the secondary current which we get through the oscilloscope of the CT. Now my teammate will explain the third part of the implementation.
MATLAB Simulink. So on the primary side, we feed 100 amps current source to the primary circuit, and the secondary part is connected through MOSFET, which is connected in series with burden, and it is connected in parallel with the device. So the pulse or the gate pulse for the MOSFET comes from the MCU. The MCU shorts the MOSFET for every 60 milliseconds. So when the MOSFET is shorted, the current flows through the burden, at the same time it flows through the device, but at this time the current is measured, current signals go sent to the microcontroller for measuring the current. So when the MOSFET is opened, the current flows through the device, powering the device. So with the help of the circuit, the CT can be used to power the device, at the same time measure the secondary current. The rating of the CT is 2000:1 amps. So this is the output graph of the circuit before saturation, when there is no change in frequency. As you can see, the first graph shows the pulse graph which comes from the pulse generator in the MCU, and this is the secondary current flows through the burden when there is no saturation. As you can see, there is no distortion in the output waveform. After the saturation, when there is a change in frequency, you can see there are clipped waveforms in the positive half cycle. This is our high level plan for converting our POC to MVP. So this is the cost for POC versus MVP. And in the result, so with the help of a solution, a CT can be used to measure input current while powering the measuring device intervals efficiently while avoiding CT saturation. And these are the references we used for our project. And thank you for giving this wonderful opportunity.